Okay, welcome to the SolidWorks. We're going to be doing an assembly today. Specifically, what we're going to be looking at is assembly basics, inserting components, and what's the difference between a fixed component and a floating component. So fixed versus float. Mating planes with planes, that's a good practice. The mate types such as coincident, concentric, perpendicular, and parallel, and also a distance mate, creating distance mates, and we'll be mirroring components. So let's start out with looking at the assembly. I've already got the assembly put together, and what we'll have is a series of mates, and when I mouse over top of those mates, you can see what I've done is I'll start by bringing the axle in, dropping the axle on the origin, and that will create a fixed component. The first component I bring in, I drop on the origin. I'll be creating concentric mates, coincident mates, meaning planes. We'll be using planes here, plane of the axle, plane of the wheel, and those planes are touching. That will center the wheel on the axle. Another concentric mate, a distance mate. If we look at the front plane here, or not the section view, let's ask for the front plane, and that distance mate is specifically referring to the face of one of the components and a plane, and so on. We have other parallel mates and so on. So let's get started. File New, I'm going to create a metric assembly, and the first component I said I was going to bring in is called the axle. I'm going to browse for those components, and there's the axle. I'm going to bring that in and I'm going to drop it down on the origin, and once I do that I see the letter F, which denotes fixed. I can right click and float that component at any time. I'm going to bring in another component, the wheel. So insert components, I'm going to pin that in place and browse for the wheel. When I bring the wheel in, I'm just going to mouse out so I can see that better and drop it down. Once I've got that one wheel in, I'm happy with that, and what I want to do here is create a coincident mate and a concentric mate. So I'll start with the concentric mate. So mate, select that surface of the wheel, concentric with that surface of the axle. So they are now concentric and that wheel is concentric with the axle. What I also want to do is if I pick the front plane, I want to bring that wheel at the center of the axle. So because I drew with the origin in the center of the part of the axle and the origin in the center of the wheel, that's easy for me to do. And what I'm going to do is simply open the axle component, and I'm looking for the right plane. I'm going to mate the right plane with the right plane of the wheel, and that is now centered. One thing we haven't done is constrain this. You may notice that my parts have some holes on or some fillets on, and yours may not be completed. What you need to do is look at the assignment and look at the information you may have missed. So bolt hole circle, for example, to add the holes, some fillets, and so on. As well, you have some extra holes in the top plate and in the axle support. So going back to the assembly, what I want to do is bring in the top plate and bring in the axle support. So I'm going to insert and bring those two in, looking for the top plate, and I'm bringing that one in, and I'm going to insert, probably should pin this in place, and browse for the axle support. And there it is. I only need one of those. I could bring in a second one. In fact, it's important for you to know that. If I brought in the second one, the axle support, of course I would need to rotate that with triad. We're going to use a different method. If I need to rotate a component with triad, I select the component, I right click, and I can move with triad by selecting the ring to spin the part around. So that would be one way of doing that, of positioning that, but we're going to look at doing that in a different way, so I'm going to delete that component. What I want to do now is bring in, I've got my parts brought in, so I'd like to create a mate. And the mate I'm going to create is a concentric mate, so I'll pick that surface of the axle support and that surface. Now what I need to do is figure out what the distance is. Now that that is concentric, I need to know what distance I'm moving. So what I'm going to do is use Evaluate, and the Evaluate tool allows me to get some information from the parts. So I pick evaluate, and what I'm looking for is measure. You need to make sure that your unit precision is in millimeters. So we can actually, I can select custom settings and how many decimal places I want to see. And what I'm going to do is select a face and a face because I need to know the distance of this part. Simply what I'm trying to do is calculate the distance that the wheel will be sitting at against this face. So I'll reevaluate that in a second, but to show you, what I'm trying to do is calculate the 136 distance of the base plate. I know my axle support is flush with that. I need to know the thickness of my axle support. I know there are two of them. If I subtract the axle support, I will get the center distance, and then I will know from this face to the center the distance divided by 2. So let me do that calculation. What I'm looking at here is to measure from here to here. So 136, and I'm going to measure again this face to this face. You may need to reselect that. Let's just reselect that. And the distance is 37. So if I know there are two 37s, one on either side, so 136 minus 37 minus 37 over 2. And that information, that calculation of 136 minus 37 minus 37 gives me 62, and I'm going to divide that. So I'm creating a distance mate here, and that may be confusing at first to you. What I want to do is select this face. Let's cancel the evaluate tool. Escape, select the face, go into assembly. I want to create a mate, a distance mate between this face and the front plane. The front plane, would it be the front? It will actually be the right plane. So the distance we said would be 136 minus 37 minus 37. That gives me 62 over 2, and I'm going to select distance, and I'm going to say 62 over 2. I'm going to ask for the front view here so we can see. So I see that there's a certain distance given there. If we look at the drawing, it's actually a little bit closer, and I think the reason being, I'm going to accept that just to show you that you can edit distance mates. If I reevaluate the thickness of this part, you may have noticed, I'll go into evaluate, I selected this face and this face, but that doesn't give me the full thickness of the part because I need to select this face so I get the full thickness of the part. So measure, let's do that again. Pick the face, and I'm looking for this X distance. You can see the red line going across is 39, so we had chosen 37. The extra 2 millimeters has come from that boss. So let's recalculate that. If I subtract the base of the top plate, which is 136 millimeters, minus the 39, minus 39, that would give me 58 over 2. And 58 over 2 is actually 29. So there are times where you need to do some calculating, and we're going to go into that distance mate, right click, edit feature, and I want this distance to be 29. So there are times when you need to calculate. When you're assembling components, you will use the evaluate tool, measure, select two faces, get your information, and do your calculation. That should have positioned that in the right place, and we can check that after. After I've done that, what I want to do, I've created my distance mate, I've created my concentric mate for the axle support, and I'm going to create, let's ask for an isometric view. I'm going to ask for a parallel mate using the front planes because I do not want this to be rotating. And if I start moving things around, that can get dangerous. I might say undo and leave that properly positioned, or I can go into correcting that by mating. So mate, and I'm looking for the axle support. Minimize these. As I hover over, there is the front plane, and I can mate that with the front plane of the assembly, and I can ask for a parallel mate or a coincident mate. Sometimes what happens is you get an over-defined message, so I can pick parallel, and let's just change that around so you see. What about if I pick, what happens if I pick perpendicular? There it rotates. Parallel, I'm going to accept that and look at these mates. So we have the axle, which is fixed. We have the wheel, which right now is underdefined with the minus sign. We have the top plate. We haven't mated that one yet. The axle support is now fully defined. So what I'm going to do is I'm going to continue mating these now. I'd like to mate the top plane using the holes given, and the extra holes you will need to add in your assembly. So let's start by creating a mate. I'm going to pick this circle and this circle, and that will mate. I may have to drag this up, and you'll notice when I dragged it, it rotated. So the danger lies in sometimes when we rotate parts too much that we don't want to rotate. So I'm going to mate those two faces, and I'm going to mate these two faces. Remember when you're watching these videos to pause and try. So I've just mated the top plate. I hit the green check mark. The mate for the top plates are hidden in a folder here, and as we roll down we can see there they are, the mates for that top plate, and you'll notice that the top plate is now fully constrained. And the last thing we need to do is bring in, we're going to mirror the axle support on the right hand side. So I'm going to go into looking here under assembly. I'm looking for a mirror components, and the first thing I need to do is select a mirror plane. The mirror plane will be a vertical plane, which happens to be the right plane, and the thing I need to do is select the component to mirror and green check mark, and that is done for me. The last thing I need to do is constrain the wheel. You'll notice the wheel can rotate, so what I'm going to do is minimize all the components, look for the wheel, and the plane I'm looking for can be, you decide, front. Which one is it? We're trying to create a mate with, and let's look at the side view. You'll notice how it rotated. Well, not the front view, the side view. And I can ask for coincident, parallel, perpendicular. You see the difference with perpendicular or parallel. It brings my hole down, so when I create a section the hole will be positioned in the correct place. The last thing I need to do is bring in a component called grease fitting, and let's insert a component and browse for that. The grease fitting is right here. Remember, when we bring in that fitting, if it's not properly oriented, we can move with triad, pick the part, right click, move with triad, pick the circle or the ring to spin the part around, rotate 90, and now we can create a mate. Now what I'm going to do is pick this face, mate with the inside of the hole, and that part has disappeared. That can be difficult. Let's undo that, and let's position it in a place where it's a little easier to see. So I'm going to ask for the front view, and now I'm going to ask for the right view and bring it in so I can see it a little better. And mate that surface with not the edge. Make sure I get the face. Do that again. Mate the face with the face. Now you may remember from watching the axle support video that there is a plane tangent to this surface, and if I look in the axle support, I'm going to roll down here, there is a plane that we created, and that plane is right here. So I'm going to pick that plane and ask to mate the grease fitting with this surface, and you see they come together, and I can ask for the right view to see that better. Okay, so that is assembling in a nutshell. Most of our parts, in fact all of our parts, except the grease fitting, because we didn't control the fact that it can spin around, and that's something for you to do on your own as well as mirroring that component. So thanks for watching.